Thank you. So a little bit of background about me. I come from a research background, and when I was in grad school, I realized that my favorite part of doing research on bedbugs and cockroaches was working with data. So afterwards, I wanted to get deeper into that and learn a lot more. So once I joined the ChiPy Mentorship program, I had a few goals in mind. I wanted to get more experience with Python. I had played around with it a little bit, but really I hadn't ever done anything before. I also wanted to develop deep learning algorithms because most of my analysis research before was more statistics-based, and work with large data sets and cloud computing, because that's not something I'd done either. And then lastly, get hired as a data scientist. So you all know the data science pipeline can go from starting with your business question all the way get to business answer. It's a long process, and about 80% of this process can be taken up by this part of the pipeline. So for my project, I wanted to choose something where I could cut down a little bit on that, because I knew I was going to have such a high learning curve. So I chose to work with a Kaggle dataset, and the dataset I chose was the TSA passenger screening algorithm. So the problem that they're having is that their current algorithm has high false alarm rates. People have to be pulled out of line and go through additional screening when that happens, and it creates long lines. And their challenge to the data science community was to create an algorithm with a lower false alarm rate. So Kaggle already took care of this part of the data science pipeline, so I could jump right in with exploration. So some of my anticipated challenges for this project, this is my first Python project, and I had to learn all sorts of basic things like what my command prompt is and stuff like that. So it was going to be a lot of things to learn. The file sizes were pretty large, so that could lead to some long run times, and I just have a desktop at home, so not a supercomputer or anything. And then it's just a large scope of a project, so it could take a long time and a lot of money to fully train it, even using in the cloud. So my plan of attack was to start small with subsets, scale up locally, and then run in the cloud lastly. So when I started exploring the images, they're from the body scanners, and it takes a 360-degree shot of you. And there were 3D images, almost 1,200 total, and the whole data set was 3 terabytes. So this is an example of one of the higher resolution images that they gave just to see what that looks like. It's a pretty cool 3D shot. But they actually recommended starting with a lower resolution images that they provided, which were only 10 megabytes each. So when you read it in using the function that they gave you, you get an array with samples, dimensions on the inside, and then channels last. So what I decided to do was start with a small subset using a couple of the body zones. They had divided the images up into these 17 zones, or I'm sorry, the images weren't divided, but that's where they have threat labels. So when you crop all the images down, there would be almost 20,000 threats. So I wanted to just start with 2 of those. I started with zone 5, which was on the front, and zone 17, which was similar on the back. And the first thing I wanted to do to pre-process it was basically take this complicated 3D image classification problem and turn it into a 2D classification problem so that I could plug it into other tools that are already existing out there. So take the array that we had before and isolate all of the 16 channels for the images. Then take the 2 channels where it had the best shot of zone and crop it down and save it into a PNG file format so I could use other tools more easily. So this is what one of my models looked like. I trained one for each zone. Had a few convolution layers, some fully connected layers, and then finally I used Keris's image data generator to augment the images and kind of get a bigger data set by rescaling them, cropping them, flipping it, stuff like that. And then lastly, I have a preliminary pipeline where you can take one of the original scans, crop it down to a PNG file, put in a model prediction, and if it's predicted a threat, it'll be a flag. So each one of these represents like one image, one person, and then you can see the flag. So my model 17 was pretty good. I had 95% accuracy and 86% recall. Zone 5 still needs a little bit work, but the TSA's current algorithm has about a 5% recall rate. So I take that as a win. So this is what you can do in 3 months from basically going from Hello World to learning some Python. So thanks for coming tonight. Thanks to MPUB for hosting, and thanks to the mentorship program, and especially my mentor, Chris Gruber, who's been a tremendous resource throughout all this. Thank you.